Okay, our next speaker is Mark Reggers from 3M Personal Safety Division, and he will provide an overview of respiratory fit testing, pros and cons, and how to introduce fit testing into a workplace. Thank you, Mark.
Good afternoon, everyone. Hope you're doing well. Thank you for having me, for inviting me along. I'm actually from New South Wales, so it's fantastic to be down here for the week. Though the only downside about being down here is being away from my family. I've got a little boy who's 1 year old at the moment, which is really exciting. And when I am actually home, one of my fatherly duties is actually to change his nappies, and it's a very important task. And I think I'm getting very good at changing nappies, but sometimes I will put a nappy on and it's not actually on pretty correctly. And that is what we call a potential blowout situation. So I don't know if you've got any parents here who have been through that situation. And when you have that situation, there is a moment that flashes before your eyes that you think, how can this little human cause so much devastation, carnage, and leave a trail of destruction from this little moment? There's also a moment where you flash back before your pre-child life and you think about, how did I ever end up in this situation in my worst nightmare? But here you are. But if you think that is bad, that's nowhere near as bad as a worker wearing a respirator, thinking they're being protected, thinking they're being fit. Because the potential consequence of that situation is an irreversible lung disease that we spoke about earlier today, versus the consequence of my situation and changing nappies, I can wash my hands. You can't wash a worker's lungs clean. And this is why respiratory fit testing and respiratory protective equipment is so important. Now, I know with Martin's presentation we spoke about P2, and you're probably very familiar with P2 filters being a filtration rating, but a filter is one part of the equation ensuring a worker or your workforce are actually achieving protection. So there's a combination of three key areas that you can highlight here. Number one, filtration. That's a pretty important part. But guess what? If it doesn't fit your face, it really doesn't matter how good that filtration is, because you are still going to be exposed and still going to be breathing in an amount of that dust that you're wearing a respirator to protect. I just want to go back to the question before in the previous one about whether these filters actually can filter the small particles as well. So the hardest particle size for a respiratory filter, or a HEPA filter, to capture is around 0.3 to 0.6 of a micron. So 10 micron in the scheme of respiratory filters is huge in the schema, so it captures it very, very efficiently. So you may have heard about a P2 needs to be 94% efficient against the hardest particle size to capture, which is around 0.3 to 0.6. So a 10 micron, 8, 5, 4, 3, 2 size micron gets captured really, really effectively by the filter. But once again, it really doesn't matter if the filter's there, that's great, but if it's not fitting you, you're still going to be exposed. So there's three key areas that we're thinking about. So I'm really going to be talking about fit testing and the importance of fit. Fit. If you take nothing away from what I say today, fit is very, very important with your respirators. So what does the Australian standards cover around fit? How does it identify fit? So in the standards, it needs to pass for a total combination. It needs to fit 10 people, and we'll do what they call a total inward leakage test. 10 people. That's not many people at all. You think about the size of this room here and how many people we've got. You think about your workforce. You think about the diversity of workforce. That is never going to be representative of every person that's going to potentially put on a respirator. As a manufacturer, we don't say, and all manufacturers would say, one size does not fit all. One style or brand does not fit every single person the same. The variability is the fit. We are all different. Face shapes, dimension, nose, scars, face, on everything is very quite different. So it sort of covers it from a very basic point of view, but doesn't cover all scenarios as well. What does the first P in PPE stand for? Personal. And sometimes we kind of forget what that first P means, because a piece of PPE or respirator's got to be right for you. It's got to be right for the person. Sometimes PPE can fall on that consumable thing where people need to purchase a lot, so it becomes about the price and availability and all that kind of stuff that needs to come into it at some point. But if it's not going to be right for the person, it defeats the whole purpose. I mean, if you're needing to wear PPE, it's no less important than any one of your other controls. So there's a couple of really key areas when I talk about fit broadly with tight-fitting respirators. So facial hair, I've got on the slide talking about there. The training of the people and knowing how to fit the respirator, the fitting skill of the person. You know, they talk about in the Australian standards about makeup. So what's those things going to affect a mask moving around on a wearer's face? And I personally haven't come across too many sites myself where makeup is an actual issue, but anything that's going to affect that mask moving around. Other PPE. Well, now we've got safety glasses and a respirator as well. What impact does that have on the fit and where it sits on your face? These are all important factors that go into making or breaking a fit or a seal on a respirator. Facial hair is a tough one, in that from the male population, facial hair is a moving target. It is always changing. I remember being in high school and there's kids there with a 5 o'clock shadow in year 10, versus I've just got there now and I'm, 20 years later. So this is a picture from one of actually my facial hairs, and I use this quite a bit when talking about fit testing and education about the seal between the face and the mask. So we're talking about respirable crystalline silica. So respirable at 10 micron and down. So here's my beard stubble hair. Thank you, Gillette, for a lovely nice cut there. But here's a range of different particle sizes measured compared to our facial hair. 5 micron, we're getting smaller and smaller with that cutting and that process as well. So we're thinking about that dust that we can't see. So usually from about 40 micron down as humans, we can't actually see that size fraction. The Tyndall effect was in perfect demonstration there with the light. You think about it on a nice sunny day in your lounge room, you can see the floaties floating, and that's here, that's in this room as well the whole time. So this is why wearers need to be, of tight-fitting masks, need to be clean-shaven, because that seal is so important. Now, has there been studies to show what kind of drop-in protection? Absolutely. So here's just a couple of excerpts from a couple of studies I usually talk about. So this is one study showed that face seal leakage increased from 20 times to 1,000 times in the presence of facial hair. Significant numbers there. At least a 330-fold drop-in protection was experienced by bearded workers. So that has a huge impact on the expected level of protection from a high-level concept point of view. Now, we're talking about fit tests. Now, you may have heard of fit check as well. I just want to clarify the difference between a fit test and a fit check. What we're talking about today is fit test, which is a process that checks. A fit check, or user seal check, is you may put on a respirator or a filter, you may cover the exhalation valve and you sort of blow out and you'll feel that push out, or you may cover the inhalation valve and suck in, that mask will suck down. So that's sort of a crude check that a user should do every single time they put on a respirator. I like to think as a fit test is like sizing up your shoe. So we've got the right size for our shoe, but you still got to do your laces up. So the fit check is doing the laces up. The fit test is sizing the shoe for your foot in very simplistic analogy terms. We need both of those as well. So a fit check is not the substitute for a fit test. Now, fit testing has been the current Australian standards since 2009, but the actual concept of fit testing is actually not new at all. So this is a nice little video from the 1930s, and you can Google YouTube 1930s fit test, and this is what they used to do in the 1930s.
To make sure it would fit various kinds and sizes of faces, it had to form a dust-tight seal on all types: the long and narrow, the medium, the round and full. To test security of fit.
So a bit more of a qualitative visual type fit test. Now obviously I just want to reassure you this is not the current methodology we use today, but the concept's not new. 1930s they were talking about this seal of the mask is very, very important as well. But usually my first thought always goes to what about the exposure of the person doing the fit testing as well. But so this concept is not new, as much as many workplaces are hearing about it for the very first time with regulations changing.
But his lungs are clean.
And so fit testing has been around for a very long time, but I guess what's changed in the last sort of number of years is that off the back of the angiostoma, the silicosis cases, the pneumoconiosis with your black lung type stuff, a lot of the regulators around the country are now enforcing there's consequences for not fit testing. It's always been there. So what was used as best practice that only big companies would do, this is minimum standard compliance. So it doesn't matter if you're one person who's got 100 workers, that is important. The seal, doesn't matter who you are. So the concept is not new. So what we're going to try and do is give you a real high level overview of fit testing. So what type of respirators or masks need to be fit tested? Any tight-fitting face piece, so that could be a disposable mask, a half face, a full face, SCBA, they're the type of masks that need to be fit tested. So we want to confirm that mask fits your face, that mask fits your face as an individual. That also includes positive pressure tight-fitting masks. So you may, in the asbestos industry, they'll have PAPRs and they'll have a tight-fitting mask. We think about fireys, they may have self-contained breathing apparatus with a tight-fitting mask as well. All of those need to be fit tested as well. You would fit test under negative pressure, but that's sort of the range of masks that need to be fit tested. And most commonly, you're probably going to be looking at disposables or half face or full face in general industry. What type of masks don't need to be fit tested? Loose fitting head tops attached to powered air purifying respirators do not need to be fit tested. The concept of these work in a high volume or flow of air coming into a head top. The air is pushing out, escaping from the seals, and so essentially you've got like a bubble of air on your head, and that's pushing out, not relying on that seal. So often the question goes, well, why do I need to fit test those if that's positive pressure as well? The reason being is they have a higher assigned protection factor. So in the Australian standard, something like that on a positive pressure is 100 plus, that is 50. So the assigned protection factor is based off the seal and the positive pressure being achieved as well. So if you're using that in environments that you're 20, 30, 40, 50, 60 times over the exposure standards, you want a high level of confidence that this is whatever you're using is going to actually protect you. So when do you conduct fit testing? Generally, it's the first time you've worn a respirator or you're introducing a new product, that's when you would conduct fit testing. You want to do fit testing before they're going to be wearing the mask. You don't want to be fit testing after the fact, because obviously that may be too late, you've already put them in an environment. The Australian standards and the new ISO fit testing standards recommend that fit testing should be conducted annually, because our face shape, size changes over time. So there's been some studies that show percentages of face shape variations over time, but it's also a good training opportunity as well, which we'll go to. Dental work, facial changes, you may have scars on your face. We change, you're probably not the same face when you look in the mirror as you were when you were 20, maybe getting into a trade. So it's an ongoing process to check that whatever you're using is continued to give you a seal. Now, there's two broad types of fit testing methodologies. There's the qualitative and there's the quantitative. The most common method in Australia, qualitative, is this what we call a taste threshold screening test. So this picture here sort of highlights, in very simplistic terms, what's actually going on there. So there's actually an aerosol spray that the wearer will taste. And before we get to this stage, we actually check that the person can taste it. Maybe you just can't taste the actual aerosol spray. Depends on how many sprays you use will guide how many top-up sprays you do throughout your test. But the simple the concept is that if you're achieving a good seal, you would not be able to taste the spray that's getting sprayed into the hood because you're getting a seal. If you can taste it, well then you are not getting an adequate seal with what you're doing. So in the very high level concept, that's simply how that works there. Now there's pros and cons with both methodologies. So when you look at the quantitative method, so we're relying on the person in this case to actually tell us that yes, I can taste it. So we're relying on them to subjective, they're telling us. Versus a quantitative method, we have an ambient particle counting method and a controlled negative pressure method. The most common one in Australia is this ambient particle counter, porta count machine if you're familiar with fit testing. And what this machine is actually doing, you would connect this up to the respirator and you then get a hose inside the mask, and what it does actually counts the ambient particles outside the mask, counts the particles inside the mask, and compares it from a ratio point of view. Because you think about a respirator protection point of view, if I've got the same concentration outside the mask as the same concentration in the mask, what's the respirator actually doing? We're wearing it to reduce the exposure. So that uses the ambient particle count in the area. Controlled negative pressure measures the air leakage. So it actually sucks all the air out. You've got to hold your breath, it sucks all the air out, and it measures how much pressure drop actually happens inside the mask as another fit test methodology with that as well. So it's Australian standard, the ISO, there's pros and cons with it. Already? Oh my gosh, I need to fly. There we go. Well, there's pros and cons with both methodologies as well. So the Australian standard doesn't talk about one is better than the other, but there's pros and cons. So some of the pros with this one, from an affordability point of view, $400 to $500 roughly. Those machines are about $20,000 to buy a machine like that. So it depends on what you're doing. So understanding what the pros and cons are, you need power for this one, you don't need that, but this is non-subjective. So the different methodologies, and I'll fly through this for the sake of time, so depending on what mask you've got on site, will sort of guide you down the path. So full face masks must be fit tested on a quantitative machine because we've got higher fit factors, versus these lower ones, the qualitative has an equivalent to a fit factor of 100, which is suitable for half face masks as well. So knowing what mask you've got on site or which way you go down may be guided by what you're actually using on site. Through a fit test, it's not about trying to, you could wear a respirator and you may not move, and you may get a seal. that you are moving, you're doing your job, you're climbing, you're moving things around. So we want to get a respirator that can maintain an adequate seal through a series of exercises. So in the actual fit test, there's different exercises that it will actually take you through to simulate a range of movements. So normal breathing, deep breathing, head up and down, side to side, you're bending over to simulate a range of movements because you move on the job, so we want a respirator that can achieve that adequate seal. Normally there's 60 seconds per exercise. End of last year in the US, there was a new 2.5 minute protocol that got approved. So on some of the newer machines, the actual fit test itself may only take 2.5 minutes as well, but I can talk to you afterwards about that because there's a fair bit, that whole process there. Fit testing takes time. So we talk about the test may only be 7 minutes on the other one, or maybe you're doing 2.5 minute test, but there's a whole bunch of other things around it that still need to happen from a fit tester's point of view. So you're looking at maybe 10 to 20 minutes per person, depending on their background. So obviously you want to show them how to fit the respirator. The protocols talk about a 5-minute comfort assessment period in there as well. You need to show them the user seal check. Obviously you may do retesting if they may fail the fit test to may try. So you may put a mask on, start the fit test, you may fail, you may need to go to another style or another size. So fit testing takes time. Depends on, I've done some people and it takes 10 minutes, the next person takes 40 minutes because I've just have to take multiple masks to find a mask that actually fits them. So who can conduct fit testing? Australian standard doesn't really specify or detail any sort of competencies, but the new ISO standard goes into detail about the competencies a fit tester should actually have. It's not just about I know how to use a machine, but it's all that understanding around the actual fit testing process that is important as well. Now this can be an internal service, nothing saying that as an organisation you can conduct fit testing yourself, or you could be engaging an external consultancy or a fit test provider that does that as well. It can be either. One of the things I'm involved with the Australian Institute of Occupational Hygiene is to try to introduce a national training and accreditation scheme for respiratory fit testing to bring in some consistency. We've seen all different practices across the country, some quite good, but majority not very good. Best intentions, but understanding the nuances and the confidence of the fit testing is important. So a couple of areas very quickly before I nearly finish up here is that here's some of the common issues I guess we see as far as it being in the respiratory space where fit testers go wrong. A lot of the time they don't have an understanding of fit testing, and I say that very broadly where they've watched a YouTube video, it could be one of our videos, but they don't understand respiratory protection or the whys of what they're doing, or what do you do when your mask doesn't fit, how do we assess that side of things. When we start talking about the quantitative, where they probe the mask will be in the wrong position. So probing it there and there, that's going to be no hose into the actual mask area. You're going to get really, really high fit factors, but that's not actually representative of what's actually getting inside the mask. A common one is not checking if workers have smoked in the last hour before the quantitative fit test, because that exhaled breath will exhale particles and the machine will count that and that'll think that's particles coming in from the seal as well. So they're little things, but it goes to the confidence of the fit test process and who they're actually doing that. I'll skip this slide. So what impact does fit testing actually have on the job? Because this is what it's all about. I mean, I can talk about here in numbers as a hygienist as well, but what impact does fit testing actually have? So this is from a cohort, it's about 13 studies where workers were fit tested. This is from 4 studies where workers were not fit tested. So they were using a half-face mask, which has an assigned protection factor of 10. So what we want to see is workers above that line there. So if out of the 13 studies that workers were fit tested, 98% of the workers achieved the assigned protection factor or the expected protection or above. We're only aiming for 10 as the minimum. We've got workers getting 1,000 times reduction, 10,000 times reduction. So you can get really high reductions, but these numbers are set to cover all workers versus these group of workers who were not fit tested, only 55% achieved the assigned protection factor above. So it's not saying that you may not get it by not doing fit testing, but your likelihood goes from nearly 50-50 flip of a coin to maybe your workers getting adequate protection to really high 90% as well. Because you can pass a fit test today, that's great, but if the worker doesn't put it on their face and do the right thing tomorrow, it doesn't matter about the fit test. It's all about being protected on the job. So this just goes into the next, summing up here, that fit testing is an important part, but it's not the only part of a respiratory protection program as well. We're trying to improve the confidence that workers are getting achievement protection every time. Up the back there, we've got a fit testing white paper, which goes into all this stuff into a lot more details. It's a 14-page document, and I've really squeezed this in. I could talk for days on this. I get way too excited, but anyway, this is why I work where I work. So hopefully just highlighted the importance of fit testing, and if it's not something you do in your workplace at the moment, you really should be looking at what you can be doing, whether you do it yourself or engage someone else, because it is really important to give confidence that workers are being protected. Thank you.
Wonderful.
Right in 20 minutes, perfect.